Okay, in this video we're going to convert between degrees and radians. Well, before we do that, we have to talk about what a radian is, which is, really very important. Maybe, more important just than what a radian is. Converting. It's like, what is a radian? You need to think about that. Okay, so if you draw a circle, on your page, your circle is big or small, or it might be, really big circle, really small circle. You look at the circle that's drawn, and you look at the line from the center to the circle, and that line segment has length 1 radian. It's the radius of the circle, 1 radian. Now on my page, I'm estimating that's like 2 centimeters or something. It just depends on on the circle. So we call it 1 radian. Now that's a unit. It's a unit of measurement, 1 radian. And if you make a tape, like say you have a tape measure or maybe string, and you mark off your measure so that there are marks that are spaces which are this distance, 1 radian apart, and then you take that tape measure and go around the circle, you're going to see that it goes around the circle around 6 times. I mean, you can sort of figure it out here. If you sort of matches up with the chrome part of the pen, it's going to make it, if you go around, it's around 6 times. Well, then the actual number is 2 times pi times. So the circumference, if you remember, is given by c equals 2 pi r. A pi is defined as pi equals the circumference over the diameter. And the diameter is 2 times the radian. So now what's the unit of our radian? What's r? R is 1 radian. You could put in this formula, r is, say, 2 centimeters, and then you punch in this formula. So centimeters, okay, what about 2 feet or 2 inches? Whatever number it is, the radians. But I'm calling this unit a radian. And there are 2 pi radians in a circle. Okay, so if we can believe that and buy into that, then we can see that 2 pi radians is the same as 360 degrees. And that if you divide by 2, we get 2 pi radians is equal to 180 degrees. And that, all right, so there you have it. If I have 1 radian, this is around, well, no, it's not around. It's exactly equal to 180 degrees divided by pi. And so that's going to be around 57.3 degrees. So remember that pi is around 3.14. Now, when we use degrees, we put the little degree symbol. But when we use radians, we usually don't put anything there. Calculus is using radians. So a lot of people, when they begin learning angles and trigonometry, they use degrees and they want to stay with that. And but the truth is that in calculus, it's just almost all radians, because it's not just like a thing, like a culture thing, like, well, that's what we do it in this country, in another country we do something different. It's not like that. It's because of the way math turns out it's mathematically that's the way you should do it. It has to do with the way things work out. So let's go ahead and do an example where we convert, actually do what I said I do, which is convert between radians and degrees. Okay, so convert from degrees to radians. Okay, so let's just start off with 60 degrees. So the solution is that we take the 60 degrees and we multiply by this factor, which is pi for every 180 degrees, pi radians for 180 degrees. So when I write pi, I don't write radians. It's just understood it's in radians. Now, the units cancel out. The degrees cancel out, just like with a fraction. Here's we have a degree in the numerator, degree in the denominator. So our answer is going to be in radians. And then what we can do is we can reduce dividing numerator and denominator by 60. We get 1/3 pi, or pi over 3. I would say for the most part, it's a bit of trouble. I think there's somewhere on the calculator, I haven't really looked at it, where you can press some buttons and you can calculator will do this for you. But anyway, okay, so I have pi in the numerator, 180 degrees in the denominator. I want the degrees to cancel each other out. Numerator degrees, denominator degrees, they cancel each other out. And then I'm presented with the task of trying to figure out how to reduce this. Well, so 45 goes into 135 3 times, and 45 goes into 180 4 times. So that's 3/4 pi. But we'll see that what we're going to do is we work a lot with special angles, which are going to be multiples of 30 degrees and multiples of 45 degrees. So there's a bit of memorization that comes up. Okay, so now let's do another example where we start with radians and we then find degrees. All right, so if I have, say, 5, 6 pi, if I don't write anything, this means radians, okay? So what I do is I again multiply by a factor that involves pi and 180, but this time I put pi in the denominator. And this is 5, 6 pi radians, and then pi radians, the units cancel out, and we're going to be left with degrees. So pi, of course, cancels out there, as we see. And so we have 5, 6 times 180, and that's all degrees. And then 6 goes into 18 3 times, so we get 5 times 30, so that's 150 degrees. And then let me just point out that you could have something like 1.7 radians. And this, I sort of broke down and wrote down radians, but in general, you won't see that. It's just understood to be radians if you don't see any units. And then in this case, it's, anyway, it's just, that's what you get. And you can at least multiply out the numerator if I can find a calculator handy here. But so this makes 306 degrees divided by pi, and there's a real feeling of people saying that, feeling that they should write this as a decimal. I'm just saying, I'm going to say that a fact that if you do that as a decimal, that will be an approximation because pi is an irrational number. And I know that maybe in a science class or some classes they want you to write decimals and round it, but mathematically it's just the truth is that this is the answer. Because anything else, when you use pi, if I write a decimal, is an approximation.